able to understand. Along the way, you need to have a one notepad where you basically sort of like have a IT dictionary. Whatever word I throw at you, if you don't understand the meaning of it, write it down, ask me later, or go to internet and get the definition so you can build up your IT dictionary. The lingo is very, very important in the IT industry. If you understand the terms and if you understand what they mean and what's the true meaning of it, then you have half of the battle. Your focus should be learning, honestly speaking, learning the skill. And I'll tell you the value that it has. I don't care where you are. You're in UK, you're in Canada, you're in America, you're in Pakistan, you're in Dubai. The value for learning the skill is there. Okay, it's a very foundational skill. Everything sits on Linux, and that's what I'm going to teach you in this class. So, can we focus on the learning part? I want you guys to learn. I want you to pick up a skill. I want to intrigue your interest. I want to teach you. I want to make sure that um, whatever I'm teaching you, you're understanding it and you're getting it. Let me start with my PowerPoint. Share my screen over here. And let's start with this PowerPoint over here. Now, so I'm going to start off with the very basic definition of what is information technology. When you hear the word information technology, what comes to your mind? What do you think is the IT's definition? If you could give me your own definition in the chat, would appreciate that. The definition of IT is the use of computers, networks, and systems to manage information and support various aspects of your daily lives, from communication and work to entertainment and innovation. So basically, information technology is the core of our today's life. It's backing up everything that we touch today, from the cell phone, refrigerator to cars. Anything that we consume today, anything that we use today has to do with the IT industry. It's either designed at some point on the computers, it's either some data that you're using, it's a cell phone if you're using, it's all backed up by IT. So the use of computers, the use of networks, the use of the data and storing data, it all falls under the IT industry. And it has a great role in our day-to-day life. Okay, so that's basic definition. Everybody knows what IT industry is. Information technology basically is moving our life, is supporting our life today, and even tomorrow is going to be more apparent. It's going to play a vital role when AI it takes over everything, and that's the robotics, the autonomous cars, um, everything pretty much you do will be pretty much replaced by the AI agents or AI robots, and that's obviously is being done by the information technology. Why should you care about IT? Once again, like I said, it plays a very vital role in your daily life. It basically enhances convenience, connectivity, and productivity. If you use the IT to your advantage, you can be more productive. It can make your life easy. And a lot of the exciting projects are derived because of the IT, whether it's NASA launching, or whether it's cyber warfares, whatever you touch today has to do with the IT industry. So that's why, and also now more than ever before, like I said, AI is going to play a very vital role. I think it's a very exciting time for you to learn IT. It is going to become essential for you to be familiar with the IT, because everything that you touch, even today or tomorrow, is based on information technology, IT. So IT is a broad term, and then it has all the technologies under its umbrella. That's what the IT is, information technology. How IT is shaping the future. Well, IT plus data plus AI is helping you make smart decisions across any industry. And you see the presence of cloud platforms like Amazon Web Services and Google. They are replacing the traditional infrastructure. In traditional infrastructure, we used to have physical desktops, laptops, wires, data centers. Now the cloud computing is changing that. You don't require a physical server anymore in order for you to run your company, in order for you to work on the idea that you're developing, in order for you to innovate in any domain. You can just go to the Amazon Web Services, Google Cloud platform, or Microsoft Azure platform and buy a server or rent a server and run your infrastructure on top of that. Okay. And artificial intelligence, which is also known as AI, is writing code, is diagnosing diseases, and it's driving cars, like I mentioned. So AI is all is based on the IT, and it is basically shaping our future. It is basically going to dictate how we are going to live our lives. And it's going to have a major, major impact on your life, my life, and everybody's life. Everything is going to change. The way we did things in the past is going to change. Um, you're going to have AI doctors, you're going to have AI self-driving cars, which you're already seeing in Austin, in San Francisco, in Las Vegas. There are autonomous cars. You're going to have autonomous trucks, and you're going to have robots taking over human jobs. For example, if you go to McDonald's or Burger King, there are going to be robots that are going to be servicing you. I know about 5, 6 years ago, I took a trip to LA with my family to go to Disneyland, and I was staying at a this Grand Hyatt hotel in the downtown, and I was surprised to see the first time the robot when I asked for a, I believe I asked for a toothpaste or a brush, and to my surprise, I got a phone call saying Wally is right out at your door. And when I opened the door, it was a robot actually with the tray, and there was a brush and the toothpaste over there. And I picked it up, and Wally instructed me to send him back, which basically was a walking robot. And this was about 5, 6 years ago. So imagine what is life going to be in next 5 years. This is reality. A lot of the jobs are going to be taken over by the AI. So yes, IT is shaping our future. It is scary and it is exciting times for us. So you will see now, already we're seeing there are a lot of smart cities which is providing a lot of security for their citizens, like Dubai, which is a heavily smart city. You know, you have AI agents watching you 24 by 7, cameras, security cameras, speed cameras. You know, they're watching you, they're protecting you, they're also basically policing you 24 by 7, and you feel very secure in that environment. But also there are a lot of penalties too. Yes, so AI is here, and it is also shaping our future, the way we live our lives. So if you don't understand IT, you're going to miss whole a lot, and the future will happen without you anyways. So it's a good time for you to understand what IT is, pick up a skill, and become a subject matter expert in this. Every 5 to 10 years, IT has something new to offer. You know, back in days when there was a internet, and then there was internet bubble, everybody, that learned just to write computer, they were hired by these Fortune 500 companies, Google, Microsoft, Oracle, Solaris, and they made tons of money, you know, and they had great jobs. And now it's a new era where if you know anything about cybersecurity, artificial intelligence, DevOps engineering, you have a same chance. As AI grows, the security concerns are going to grow. So, therefore, it's essential for you, whether you are a core IT person or not, it is essential for you to know how is IT shaping your today and tomorrow. Okay. Any questions so far? Am I going too fast? Am I going too slow? Um, okay, great. Yes, you'll see that this is a little bit slow paced class because I want to make sure that everybody is getting what I'm saying. Um, so keep sending your questions to the panelists, and because there's too many of you, I will not be able to answer all the questions. Just keep sending your questions to the panelists, and they're doing an amazing job to answer your questions. Okay. Thank you. Appreciate that. Appreciate your patience with me. I want to make sure that everybody understand what I'm talking about. I just don't want to entertain the techie guys over here who's already, they have good knowledge and they're here to learn about Linux and DevOps, which I'm going to teach you. This is going to be hands-on course. Uh, Most likely today or tomorrow I will be doing the talking, and the rest of the course is all about hands-on. We're going to log on to Linux servers. We're going to learn the commands, and it's going to get very interesting. I'm going to teach you the fundamentals of networking as well. Okay. uh that's a good question you asked over here. I gotta answer this question. How do you know AI won't take over the jobs that you are offering, just like it took over coding? Okay. Very good question. So I invite you to ask this question to AI and ask the AI, which we will ask together once I'm done with my slides. I will share my screen with you and we will ask the AI, hey, I'm learning this skill, and is it AI proof? Are you going to take over my job? So we will see what AI has to say about this. Okay. Please hold on to irrelevant questions right now. Focus on your learning over here. Irrelevant question is, do I need a degree? Do I need a GED? You're going to wait till 3 o'clock and I'm going to answer every single person. I promise you for that. Okay, let me just go through this slide. I'm really excited to show you the Linux world, and I'm excited to start teaching you the command line interface. That's where the fun is. But I want to make sure that everybody understand what we're learning over here. Yeah, you're right. Questions are going to derail me. Okay. So, by the way, first day of teaching is always very challenging for me as well, because all I'm doing is looking at a camera without any audiences and having an eye contact with the camera while my screen is over here. You are somewhere and I don't even get to read your messages, and you're in good numbers. So it is challenging. So bear with me. We're going to be fine. Okay. This is where things get interesting. We understand what is IT. IT is basically information technology. It has to do with the computers. It has to do with the networking. It has to do with the software. It has to do with the data. And so we're going to talk about the very core components of IT. What When you look at IT under the hood, what's there? Well, I talked about it. Um, Essentially, IT basically is based on all of these things over here, hardware. So there's going to be physical devices that IT uses, right? Software, there's going to be operating system, there's going to be applications, there's going to be databases that support your day-to-day IT operations. There's going to be networks that basically connect all of these computers, make the data information available to you, and there's data which is being made available to you. So essentially, all these are the very core elements or components of the IT, and we're going to go deeper into each one of these elements and then going to break down how these components work. Okay, so this is where things get exciting. Now, like I said, we're going to drill down into each one of these categories. Hardware elements in IT. So, if you are IT user, you're taking this class over Zoom, over a cell phone. So you either have a handheld device, which is a cell phone, or a computer, or a laptop, and that's how you are using the Zoom, which is a software, and the data, this video, is being transferred to you. So all of this operation, which is being done right now, me and you being alive and connected from different parts of the world, different parts of the United States, or maybe you're some of you are in UK, Pakistan, Saudi Arabia, you're from Dubai, you're from God knows Europe, we're all using all of these elements. If you pay attention, you got a laptop, desktop, or a handheld device. There's an operating system which you're utilizing. That operating system is either Windows, most likely Windows, or Mac, because you don't understand about Linux and Unix world. And the fact that you have a network at your home, I have a network at my home, and how we're all connected. And there's the data part, right? My video being transferred, my information that I want to show you is being transferred over the network. You see, this is what IT is. We are right now users of IT. Okay, so thanks to the Zoom software, thanks to the operating system, thanks to the databases, thanks to the networks that we're able to connect today and able to present you from from a location in New Jersey. I'm able to present you what I want to share my ideas about IT in this course through this presentation. So all of these components are part of the IT. Now, you understand what the computers are: laptop, desktop, it could be a server, right? Now, when we talk about servers, what comes to your mind? What is a server? Very servers that you worked on. Can you stand up and tell me if they were taller than you, if they were shorter than you, if they were fatter than you? And at that time, wallahi, I had not seen that server he was talking about. And I got up and I said, it's this height over here. That was my confidence. And I didn't get the job over there, of course. But talking about servers, what is the definition of a server? It's basically a powerful machine that provides resources. It's basically a machine that provides resources on the network. For example, I'm throwing a lot of words at you guys, right? Technical words. So, for example, we are connected through Zoom right now. So, me, you, and all of the people that use their services, they probably have bunch of servers. Servers are basically just like desktops, but imagine their specs way more than the desktop. And the parts that they use, they're made to run 24 by 7, 24 hours, 7 days, 365. That's, by the way, term used in IT: 24 by 7, 365. All year long, 7 days, 24 by 7, they're running. So, therefore, they may have their function is pretty much similar to desktop, but desktop is supposed to be turned on and turn off. Laptop is supposed to be turned on and turn off for some period of time, and then you shut it off. But the server supposed to run 24 by 7. It has the same components as a laptop, maybe slight more differences, but it's more durable. It's supposed to run 24 by 7. It's supposed to last you for years and years, and you don't have to shut it down, to cool it down. So the server basically is like a desktop, but it's serving it's serving its users. It's providing resources on the network. For example, you and me were connected to Zoom. There's probably a bunch of servers that made this happen. um, this video, this PowerPoint, this connectivity, all of these users connecting, all of this happened because we have Zoom have tons of servers. So server basic definition is a server is a entity on the network, a computer that provides resources to other computers. Okay, that's a server. And then the second thing is the networking devices. And we're going to get into the networking devices. What are the essential networking devices? What is a network? A network is when you take a computer, two computer, three computer, four computer, more than that, one to two computers, more than that, you form a network. Right now, we are part of a network, a Zoom network. There are hundreds of you connected right now through this Zoom meeting. And so that's because there are some networking devices such as router, switches, cables, network cards, which I'm going to get into later on. And by the way, I will give you a copy of this slide as well. Okay, we will send you the link for this one. And then there are some storage devices, hard drives that every computer has, and storage devices on the network, independent storage devices. Storage devices basically store data. They are like your hard drives, the flash drives. There are certain specific storage devices, storage RAIDs that basically stores data on them and then make it available on the network. Um, so these are the essential parts of the hardware parts in the IT industry. Okay, this is every single one of this is found in your own home. By the way, you either have a laptop, desktop, or handheld device. You do not have server, obviously, because you're not running anything, which is crucial to be running 24 by 7. If you had a website or something, then you are involved with the server. You do have networking devices. There's a modem, there's a router, there's a wireless router, and a switch in your home, which you may not have realized. You also have storage devices, which are part of your laptop, your handheld device, or your desktop. So you are using a storage device as well to store your data, right? So, so that was the hardware part. Now we're going to talk about the basics of the networking, right? Take a stop over here for 1 second. Basics of the networking, right? Oh, by the way, I love this picture because this is how, when you become part of the organization, this is how your data center is going to look like. Data center basically hosts all of your networking equipment. It has all of your servers. So if you look at this rack over here, this rack basically has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 servers. And then, you have thousands of racks. And you know uh, the number of servers, so these are all servers, and we're going to show you a server too in the next session to give you relevancy to all of these things. So first we're going to learn theoretically, then we're going to show you physically what these physical components look like, maybe in tomorrow's session, and then you would have a solid understanding of what we are talking about, right? And so um, the bigger the companies, the more servers are required, more hardware elements are required. The bigger the challenge they have, the bigger the problem they are trying to solve, the bigger the network they have, the number of servers they have, the more resources they have. I give you one example right now. How many of you are familiar with the Chat GPT? How many of you have had used Chat GPT? I'm not getting too many responses from the people over here. So ChatGPT is basically a large learning model language, and ChatGPT hosts a lots of data. And if you're a user of ChatGPT and if you're not paying for it, then you probably you experience the slowness in the ChatGPT. I was listening to the CEO of ChatGPT, which is Sam Altman. He said they need a $5 trillion to build a data center, which is going to provide all the resources to power what they want to do. And as a first initiative, uh, government, United States government, and CEO Sam Altman, they are working on a data center which is costing them $500 billion, which is being built in Texas as of now, as we speak right now. So because they are trying to solve a bigger problem, because they want every single human being using the chat gpt so they can make money, not only make money, they can consume all of your data and all of your questions. The more you ask the chat gpt, the more intelligent it becomes. So and all of these it elements are going to be part of the data centers. And that's what I'm going to talk about, why I think DevOps is the way to go as the AI is taking over. I'm going to give you the answer to that question. So this is just an example view of the data center. Now we're going to look at the networking elements. We talked about the hardware elements. We give you a broader perspective about the hardware required to run your IT operations. In general IT, what hardware is required, and we talked about a laptop or desktop. We talked about servers. We talked about networking equipment. We talked about the storage devices. These are all hardware parts of the IT industry. Now we're specifically drilling down into the networking elements and core networking elements, right? So, you would have a computer, laptop, or a desktop, or a server, which you want to network, right? That's also part of the networking, right? Then, B, you will need a switch. A switch is usually, it's like this pizza box, like this over here, and it has bunch of ports. And then every single computer on the network gets connected to this switch, right? So this is the server A, this is the server B, and then you can have a number of servers that can get connected to a network switch. And what is the job of a switch? It basically connects devices within a network. Okay, so let's just see over here. A network could consist more than two computers, right? So let's say if I have over here one computer, two computer, three computer, four computer, five computers, six computers, I would need to put a switch in between, and I am going to run a cable from each one of these devices and connect it to this switch. So what is the switch job? It basically connects all the devices on the network. What is the network? Network is bunch of computers, bunch of laptops, bunch of phone devices that are talking to each other. Now, as of now, we are part of a large network. We are not on the local area, we are on the wide area network. You have a network in your home when you have a the more number of when you have your laptop, your siblings laptop, your parents laptop, or workstation, or cell phones. You have created a network, and on that very network you have all of these devices. Okay, you have a switch. Basically, you cannot see it because it's there, because it's the one device that does everything for you. So switch connects the networking devices. Router basically So let's just say we have a network. This is my home over here. And let's just say I have, I'm going to draw these boxes over here to show that I have a device. Device means laptop, desktop. So let's say I have all of these devices over here on my network, right? So what do I need on this network in order for me to connect all of these devices? I need a switch. And then, it has some ports over here. So all of these devices are connected to a switch. Now, this is a network. This is one network. I'm going to call it a network. And now, whenever one of these computers wants to go out of this network, it would basically need to connect to a router. The router looks like, it's another device which we're going to show you later on. Not today because it's all theoretical. So now this is a device. This is called router. A router directs traffic between networks. So let's just say if I had another network over here, let's say you in your home and your friend in his home. Now you have a network, your friend has a network B. What else he has on his network? He also has a switch, right? So in order for you to communicate with this network, there's going to be also another router on his network, on your network. And then in between, there's going to be a bunch of routers which are connected, physically connected, to enable both of you to communicate with each other. Okay? To communicate with each other. So therefore, the router basically connects the networks. Again, a switch connects computers to a network. Switch connects a bunch of computers to a network. A router connects different networks. Switch form a network. A router connects networks. You got that? I'm going to repeat a lot of the information. Some of you guys are going to think this guy is crazy. Okay. And so I'm going to repeat a lot of the information. And by the way, if you're going to transition into our paid program, we are going to give you a simple test to test your knowledge, whether you've been paying attention to this program. And I'm going to talk about the number of opportunities in the DevOps program. So this is going to be on the test. What is the switch job? What is the router's job? Okay. Network is a critical part of IT. Absolutely, network is a critical part of IT. Okay. So now, if I asked you, what is the switch do on your network? What is your answer? Switch connects machines, servers, laptops, desktops to a network. So switch forms the network. You need to have a switch on a particular network to connect devices. How, whether through wire, wirelessly, it doesn't matter. We're going to talk about that later on. You using a laptop on your network, you're connected to a switch. How? Because you have on your laptop a network card which sends signals, right? Wi-Fi signals, wireless signals to your switch. And that switch is also acting like a router. It's a little complicated for home networking, right? Because one device is doing everything. So switch is going to create a network. And then when you have a network and you want to connect to other networks, meaning you want to go to your Snapchat, you want to go to Instagram, you want to go to TikTok, you want to go to your banking page, whenever you type chase.com, now you're connecting to another network because that chase.com website is not part of your network. It's somewhere else on the internet. So once you leave your network, your machine sends packets, right? To go to another network, to go to the Chase website, it goes through where? Through the router. It goes through the router. All right. It goes through the router. So the router directs the traffic between networks. Everybody with me so far? You guys all good? Let me see. Okay. At least when I ask you guys if you guys are good, at least raise your hand. And this is the only thing I ask, okay, in return, while I'm teaching you valuable skills. And so when I ask you, you guys are good, you're with me. Either you say, hey, you thumb up or thumb down. So this way I know how many of you guys are actually paying attention over here. It's not easy to learn. It's not easy to learn things when you are online, and it's very very difficult to learn things when you don't pay the price for it, because your mind is constantly telling you, "Oh, there's some catch, man. There's some catch. Why this guy is teaching me for free? God damn it, there's some catch." And you're so much concerned about that catch that you just forget about your learning. And you don't value things when it's given to you for free. But, it is what it is. Element on your network is a firewall, which basically blocks unauthorized access. Your modem slash switch slash router also has a firewall. Me, please, okay? Now, if I ask you this question on the test, what are the networking elements found on every network? What should be your answer? A device, switch, router, firewall. And then if I ask you, tell me what is the switch in simple words. Switch connects devices to a network. What is the definition of a router? Router connects networks. You have A network, you have B network. You need a you need a router in order to connect those two networks, multiple networks. So every network essentially has what? It has a switch, it has a router, and it has a firewall. And of course, you need devices to connect. Laptop, desktop, server, devices. And then what else is found on the network? Well, you probably need cables. If you're talking about the enterprise networking basically means the companies, the any company that you run into, they would need these wires. They don't do their business through wireless. Wireless, even though it's pretty reliable, but it can cut down the speed. The speed matters in the enterprise. So you would need a cable. The internet cable, you can call it RJ45 cable. The Ethernet cable, you can also call it Ethernet cable. I'm going to teach you in a way that everything will stick in your brain. And that's what I love to do. I want to make sure that everything sticks in the brain. You don't have to study over and over again. So let's take a look at the basics of networking. Um, what can you expect to see in a network? First of all, we said that it needs to have devices. Oh, go back. There you go. It could be your laptop, it could be your desktop, it could be a server, it could be your phone. And then what else? We said that it needs some cables, basics of networking, right? What do you find in a network? Devices, cables, physical wires are wireless signals. Uh, network adapter. Did you know that every machine, every phone, every server, every laptop, desktop, cell phone has a network adapter built into it? network adapter, network card, NIC, NIC, network interface card, is used to send and receive information between systems. If you're communicating, I don't care what device you're using, if you're communicating, meaning you're on your laptop and you're on the internet, whether it's a Snapchat, Instagram, TikTok, or Chase website, or Googling, or Chat GPT, or you're using the application, the fact that you're able to go online is the fact that you have a network card in your machine. So that network card can use a wireless signal, or it could be connected through a cable to your switch. This network card also needs a IP address. So now we know that every network has a device like your laptop, desktop, or server, and every device has a network adapter, and every network adapter has an IP address. We're over here for now. So now what is IP address? IP address is basically a logical address. What is a logical address? Well, every single one of you have a logical address. If you're a US citizen, your logical address is your social security. If you have a cell phone, it has a logical address. It's your cell phone number. If you're born outside in England, you have the national health insurance number. God knows what they use over there. If you're born in Pakistan and India, you have the identification number, some national ID number. That's your logical number. That's how the system recognizes you. So all the computers on the network, or rather all the devices on the network, have a logical address. That logical address for computers is IP address. Now, where do IP addresses come from? That's a discussion for another day. How does, is this a unique number? Yes, it's a unique number. Unique number to a unique network. We're going to keep it there. We're going to talk about networking another day. It's a very interesting topic. It basically runs the show in the IT industry. If you take away the IP address, everything will collapse. Everything will collapse. All the websites will collapse. Everything will collapse. As a matter of fact, if you remove any one of these elements, things can collapse in IT industry. So every network has every network. How about this? We break it down over here on my screen over here. All right, so let's see over here. Let me see if I can spotlight my video for everybody. And I'm sorry if I'm dragging this topic. I just want to make sure every single one of you get it. And then once everybody's on the same page, when we touch that Linux server, you're going to love it. Okay, so bear with me right now. So every network has what? It has a, first of all, it has a device. Let's call it a device. Device are devices, which could be your laptop, your desktop, a server, a iPhone, okay? And then what else? And then we have switch. Shalbhai, how many ports are found on a generic switch?
In the increment of 8. So 8, 16, 24, 48, and so on. You could add the switches too.
48 ports.
48, yes.
Is standard. And then each port basically means you can connect a device. Yeah. These are like ports. Or whatever. ports. Okay, so this is your 48 ports. That means you can attach 48 machines or devices. 48 devices can connect to each port. Server 1 goes over here, a laptop goes over here, iPhone is wirelessly connected, desktop goes over here. So this is your switch. Thank you, boss. Appreciate it. Now we have a router, which basically looks like this. This is how it's represented logically. Why? Because what you see is different directions. What it's doing? A switch gets connected to a router. This is your router. Okay. The switch gets connected to the router. So this is, what is this connection made through? Ethernet cable. By the way, I was asking Shahid regarding the switch because he's the expert in networking. He has the certification, certified Cisco network administrator. He's also exceptionally good in hardware servers. He runs data centers. He basically he has built so many data centers, not physically. When I say build data center, he installed servers, networking devices like switches and routers. He plays around with all of these servers. He has clients from all over the tri-state area. He manages their networking, he manages their Windows servers, he manages their data centers. He's a one-stop shop, and I'm very, very proud of him. He has, whenever I get stuck on a networking, whenever I get stuck on a hardware issue, it's a one call to Shahid, and Shahid knows it all. And I'm not ashamed to say that I'm not the expert in networking. This is the beauty of IT. You don't have to be expert in everything. You need to understand how things work for your clarity. And but you don't have to be expert. Networking is a separate domain. You need network administrators to handle that. DevOps is a separate domain, but I need to understand the workings of the networking in order for me to be good Linux engineer, good DevOps engineer, good cyber security um, engineer, good AI professional. I need to understand this framework. Even if you're a simple layman, or what's the word for the laywoman? But an average person in life, you need to understand what is this networking and how it works. So the router, routers is there, and now we said that every device has a network card. I'm going to call it a NIC, network interface card. Network interface card. This is basically a device every computer, every laptop, every desktop has. And so this network card basically gets plugged into. Now, this network card gets plugged into the switch. The switch plugs into the router. What do they both use? Ethernet cable. In your case, it uses the Wi-Fi signal. And I also said that every network card has a logical address, which is called the IP address. By the way, this is the Ethernet card. You can call it a network card. Network card. Every network card has logical address. IP address is also called a logical address. This is for your understanding, by the way. Don't tell an IT guy, I use a logical address. There's no such a thing, logical address. This is for your understanding. It's an IP address. And every IP address it pretty much looks like this. It can come in this form. I'm not saying this is exactly what your computer has. It comes in this form, 192.168.1 dot whatever. You can also see this one 10.1.10 dot God knows. This could be another number. This could be this number. It could be this number. It could be another number. But you need to have a logical address. So now your cell phone has a logical, your phone has a logical number. You have a social security number. So this is the same thing over here. Okay. And if I go back to my slide over here, what else I need to add over here? So we got the router, we got the switch, we got the device, we got the IP address, we got the network card over here. What else do we need over here? How do we protect this network, ladies and gentlemen? What is needed to protect this network? Okay, let me go back to my thing over here. We need a firewall. We need a firewall right over here. Firewall. Firewall is basically this wall that basically sits right behind your network. It basically has the access control. What is access control? Who can come to my network? What type of traffic I am letting my network come into? I have three kids, and sometimes if I want them, not to be using their computers in the middle of the night, I can log into my router and I can disable certain type of communication, text messaging, web applications. I can say they cannot use this application, and it will block that specific application for them. You know, too bad for them that they have a father who understands IT. Too bad for them, because kids like freedom, right? So that's what firewall does. It allows me to say what can you do, who can come into your network, what type of traffic they can. So now, by the way, if you take a look at this picture over here, this is a one network. This is a one network. What type of network is this, ladies and gentlemen? I'm going to give you an example. You're going to tell me. This is your home. You have a bunch of devices that are connected to a switch. The switch is connected to a router. By the way, the firewall is supposed to sit over here. Sorry, wrong location for the firewall. The firewall is supposed to sit over here somewhere. Right here, right here. Um, Now, and then this will take you outside the network. This is going to take you outside the network. Okay. Let me see if I can make this more. Okay. So now this is your home. You have your devices. The devices are connected to your switch. The switch is connected to a router. And now this router is going outside. There's a cable going outside. And so this is, ladies and gentlemen, this is called LAN. LAN. What does LAN stands for? Local area network. Local area network. Yes, boss. Thank you. Thank you so much. Appreciate that. Is firewall a software or a hardware? It could be both. It could be a hardware. It could be a software. It depends. Usually, the bigger firewall is a hardware, and then every operating system has as uses as a software. Okay. Now, now what does the LAN do? Well, a LAN basically means local area network. This is What you have over here is referred as a LAN. This the minimum category of a network. Network has types. This is the simple in your home, in the organization. One network is called a LAN because it's in a same building. eh? It's in the same building, same floor. It's a LAN. You can have multiple LANs in a same building on different floors. On a same floor, you can have different LANs. And how do they all connect together? Through a router. Every time you want to connect this LAN to another LAN, you would bring in a router. Okay. And now, if you want to geographically go outside of your home, your city, state, then there's a network called Wide Area Network. WAN. 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 Wide Area Network. We're not going to talk about WAN in this class. We're just going to stick to LAN because there's no need for you to learn about WAN for now. Okay. All right. Take a look at the PowerPoint. We talked about this right over here, how a network has these devices, right? Everybody needs to understand what switch does. Everybody needs to understand what's the role of the router in a network. Everybody needs to know that every device that's on the network has a network card. And everybody needs to know that every network card has an IP address, which is also called the logical address. And everybody needs to know that there are types of networks, one being the LAN, the other one being the WAN. And then there are more types of networks. We're not going to get into that. Networking, our domain is not core networking. We're not network administrators. We're not training for that. Everybody needs to know why we need a firewall. This is amazing if you know this stuff. It took me years to learn this stuff, but I'm just giving it to you in one shot. Okay. If you know this, you're good fit for the DevOps program. If you're grasping this knowledge right now. And the fact that you're able to focus is a great thing. Let's continue. Again, I'm going to repeat a lot of things. Some of you are going to hate me for this, but I'm going to repeat a lot of things. A LAN is a type of a network. A network card, every device on the network has a network card. So it's a hardware that connects a device to a network. By the way, if this is my network card, this is how a network card looks like. This is my laptop, and this network card is part of the laptop. So this network card connects to what? Switch or a router? Help me out with this. The network card connects to a switch or a router. Anyone that says a network card, network, by the way, your machine, when I say network card on your machine, whether it's a LAN, whether it's a server, whether it's a desktop or a laptop, a device connects to what? Network switch and a router. Anybody that says router is wrong, anybody that says switch is absolutely right. Switch. So this connects to a switch, and the switch connects to the router, and that's how things work. And every network card has an IP address. Okay, so let's go next. Take a look at this. I'm giving you another example over here. Machine A, oops, machine A, machine B. Maybe your laptop, your desktop, maybe a server. They get connected to switch. There's another machine over here. There's another machine over machine. All of them get connected to a switch. How? How do they connect to a switch? They use the RJ45 cable, which is also called Ethernet cable. Ethernet. Because the type of network we're on, it's called Ethernet. Ethernet. LAN Ethernet. 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 This forms a network A. You want to connect to network B, which is right over here, which also has a machine. By the way, any machine that's connected to a network is called node. To make it simply, node, N-O-D-E, node. Why? Because you don't need to specify it's a server, it's a laptop, it's a device. When you say node, you mean that there's an entity, there's a device which is on the network. It could be printer, it could be scanner, it could be iPhone, it even can be Android. Anything that's on the network can be referred to as a node. So, a technical word that I'm giving you, node. So, if an interviewer asks you, there's a node A, there's a node B, they cannot talk to each other, how would you start troubleshooting? They basically mean a machine, a device that's on the network. So you have a network A, you have a network B. All the devices on the network are connected to a switch. The switch is connected to a router right over here. So you need a router to connect networks. To connect networks. What is the router's job? To connect networks. What is switch job? To connect machines on a network. And let's continue. Again, network A, network B, network C, machines, yeah? They all go connected to the switch. Switch gets connected to the router goes to the internet. Yeah, to simplify it. You have bunch of machines connecting to your switch, bunch of machines connecting to your switch, um, and then your switch gets connected to the router goes to the internet. By the way, this type of icon represents a cloud, not cloud, internet. Okay, so when you see diagrams, visual diagrams, illustrations of the network diagrams, you will be seeing these type of icons, these type of picture, whatever you want to call it. This refers to, this is always going to be the switch. This is like a router. It shows that it has ports. It also shows that it has a Wi-Fi connection, and then it goes to the internet. Another perspective to look at this, another beautiful perspective to look at this is that when you go in a data center, do you guys know what the data center means? What is it, data center? Does everybody know what data center is? I want you add all of these things um, to your dictionary. A data center basically is a place where every company back in days when I was young and handsome, every company, whether it's a small company or a large enterprise, Fortune 500, 100 company, big enterprise, small, medium, whatever the company size was, they used to have a one room where they would install all of the servers and networking equipment. And that is called the data center. Oops, sorry. It's called the data center. Now things are changing a little bit, and I'm going to talk about how things are changing. Not every company needs to have a data center because of the cloud computing. This we will look at when we talk about cloud computing. But back in days, and even still this day, like if you're an enterprise means if you're a big company like AT&T, Google, Facebook, Meta, um, I don't know, you know, yes. So data center holds computers, networking equipments, servers, storage devices. They're all in one room, and this was gigantic room with a lot of air conditioning, a lot of power, and a lot of UPS as well. UPS means if the electricity, is interrupted, and there's another backup electricity, right? The UPS. So you have these bunch of servers, rows of hundreds of these servers, of these racks over here, and you have the servers mounted. This is called a server mounted in a rack. So you have these rackable rack mounted servers, and all of these servers at the end of the day connected to port 1, port 2, port 3, port 4. You see that? How each server would be connecting to a particular port. See that? This is the switch. This is exactly how a switch looks like. See that? Right over here. Now, all of this switch over here now would be basically running a one port would be going into the router, which is going right over here. This would be going into the switch one port. Okay. And now this router takes your network onto the internet. Okay. This is how you're connected to the internet. When you see that the ISP, the internet service provider, whether it's a Comcast, Verizon, they run a cable into your home from the outside, literally. And then you always have this modem sitting in your home. This modem acts as a switch, as a router, as a and also broadcast the signal wirelessly. And then your machines are sitting on that network. Another perspective to look at this, okay? So again, now we're going to talk about so far I'm going to give you another perspective on this. This is very, very interesting for you guys to, this is very important for you guys to learn this stuff, okay? Before we connect to the server. So now you have a server over here, a machine. It has a network card, right? And this network card needs some basic information for you, for this machine to connect to other machines. It needs basically an IP address. We talked about it. It needs a subnet mask, and it needs a gateway. Okay. If you have all of these things, which is called the network configuration, then your machine now can, using the cable, can connect to a switch, and then this switch essentially gets connected to a router, and this is how the communication takes place. So for every machine that's on the network, on the internet, this is all they have. They have network configuration, basically IP address, subnet mask, and a gateway. How they assign all of this, we're not going to talk about that right now. This is the essential. Your router is doing all of these things. Okay. I'm not going to go into the detail of this right now. I will explain you this down the road because this is very essential. But for now, I just want you to understand these basic things. These basic things are required for your machine, device, server, laptop, desktop to be on the network. This is the minimum requirement. A network card, that has this configuration, and then it gets connected to a switch. The switch is connected to the router. Everybody okay so far? Any question that you guys have over here before I move forward? Yes, what's the question? Please send your question quickly so I can answer this for you. Okay, you're okay. Good. Rick, you're good. Ali, you're good. What is the subnet mask? The subnet mask defines. Okay, all right. Let me break it down because you guys are interested in this. I hope this is not too much information for you guys for the first day. You guys are okay? Or this is too much information for you guys? IP address is basically a logical address, just like a phone has a logical address, right? So other phones can connect you to connect with you. Just like that, every machine has an IP address. The subnet mask defines the number of devices your network can have. Number of devices, to very simplified version, Rick. I don't want to complicate things over here. I know that you have good understanding of this stuff, but for everybody else, I'm giving a very, very basic definition. Gateway is basically the IP address of your router. The IP address of your router. Remember, a router also has an IP address. Okay? A gateway is a physical device. Gateway and a router is the same thing. Gateway and a router is the same thing. Why is it called a gateway? Because it's like a gate to your home. The traffic that's coming in goes through this gateway. The traffic that goes through this gateway. For example, if you're sitting on your laptop and you want to go to Google or ChatGPT, it's going to go through this. When you type chatgpt.com, the packets leave your machine, go to the switch, then go to the gateway. And then gateway knows where to send it next. Okay? So this is a hardware device. This is a hardware device. This is hardware. And then these are logical things. A configuration like this computer would need to know all of these things. How does this computer know? There's a mechanism which is automatically there's a service that does all of these things. We don't need to worry for now. So every computer needs to know the IP address of the router so it can go to that router. It knows to connect to that router. Okay? That's it. We're gonna stick to this over here. So now if I go back to this slide, and we will see if we understand all of these things over here. Again, the IP address, where's my pen? Right here. The IP address is the logical address, unique address of the device. The device is your laptop, your desktop, your server. Subnet mask defines the network portion of the address. Define how many devices you can have on the network. Default gateway, a device that connects the network to another network, basically the IP address of your router, the IP address of your router. So if you look at this, this is a classic example. This is the IP address. This is how the subnet mask is written. This is usually the gateway, and the DNS, we're going to come back to this later on. And every machine has a network card. The network card gets this configuration, and this is the minimum settings for a machine to communicate on the network. Minimum settings. Now let's come back over here and talk to me what we have done so far. We talked about the definition of the IT. We looked into how the IT is running our day-to-day life, and IT's involvement, the technologies that we use, we rely on a daily basis. And then we talked about the basic elements or components of the IT industry. We talked about the hardware element. In the hardware components, We talked about servers, we talked about desktops, we talked about networking equipments, and we talked about the software. So again, basically, if you look at IT under the hood, it has some hardware, it has some software, it has some networking. We looked at the hardware components, we and we talked about what are some of those hardwares. Now we're going to drill. We looked at the networking equipment, then under the network, what's inside the networking, right? Hardware, software, and networking. We looked at the networking part. The networking basically relies on your network card, switch, router, and this configuration. That's all there for the networking and the cables. Now we're going to drill a little deeper into the hardware aspect, the server side. Okay? And then we will see what's inside a server. What is the definition of a server? What is inside a server? What are those components doing? Talk about over here for a second. What is a server? A server basically is a high powered computer that provides data, services, resources to other computers across a network. Very difficult definition. But basically, what is a server? I want you to consider your laptop for a second and think of it like this is the server for you. And laptop basically enables you to communicate with other devices. It enables you to surf the network, the internet. Basically, it allows you to use some applications like Microsoft Word, um, Zoom, the application that you're using, Skype, which was the thing of the past. We don't use that anymore. But any application that you can, that you need to use, you need a laptop for that. Now imagine if you decided one day that my laptop is going to store all the family pictures on my laptop. I'm going to store all the family pictures. And then everybody in my family that needs to view those pictures, they are going to basically access my laptop through their laptop and then view those pictures. Now your laptop's definition has changed. It's not a workstation anymore. It becomes a server. It is serving something. Now, one more time. Now it becomes a provider. It's providing a resource. What is the resource? The family pictures. It's providing over the network to you. Okay? Now, imagine a company called Google. Google, by the way, was a thing of the past, and now it's a thing of the past. Google used to store all the website pages, all the websites. So what Google did was basically it provided you all the website links. You just went to the Google website, you type in nearest bank, clothing store, shopping mall, whatever you wanted to search, shopping for clothes, shopping for medicine, whatever you wanted to search, Google gave you that search result. So now, Google, in order for Google to serve you, Google had to install thousands of servers, thousands of servers. So these thousands of servers, hundreds and thousands of servers, maybe millions of servers, they collectively work together and they provided you the results that you are looking for. That's why we are learning about a server. Server is essentially just like your laptop, but it's bigger, it's robust, it's durable because it has to constantly provide something to you. For example, in this case, Google server. They were providing the website link to you. To you, this is not a big deal. You're going typing there. Any website that you hit today, any application that you use today, including ChatGPT, including Instagram, including TikTok, is at the end of the day relying on a server, relying on a server and its components to provide you that. That's called resource over the network. You sitting at your home, opening your cell phone, going to any application like Instagram or TikTok, or these are the social media websites that are we heavily rely on, or weather application. As soon as you click on it, your cell phone is on the network. That server is sitting in somewhere in some company's data center, providing you that resource over the network. Okay. Now, when you hit any of this application, for example, ChatGPT, for example, Instagram, for example, Facebook, for example, Chase Bank, it is just not a one single server that's providing you that resource or whatever you're looking for, whatever application you're using. It is bunch of thousands of servers that's working together to make that available to you. Because if this was one server, then it would crash. Because just like your human brain has a capacity to answer questions, servers can simultaneously uh, answer the request coming in for information, but there's a limit to what they can provide. So therefore, they put together servers, which is called clustering, cluster. They put together servers, which is called cluster of servers. They work together and they provide you the resources that you're looking for. Another word I gave you today, bunch of servers put together working for the same cause, they become clusters. Okay? So now, why we need to look into the server? Because the skill that I'm going to teach you is a very foundational. That's why this is so important. That's why this is not going to go away. A server is always needed. You can never take the server out of the equation. ChatGPT, AI, machine learning, large language models, search engines, websites, applications, databases, they all run on this server. And being a Linux engineer, cloud engineer, DevOps engineers, you are actually working on these servers. You become the platform guy. Anyway, folks, I'm here to teach you foundational skills. I don't want to talk too much about my program. I don't want it to be a marketing pitch. I want to give you something for free. And so let me focus on that, if you could, please. Okay. Meanwhile, if you have questions, I'm obligated to answer your question. Okay. Um, Go back to my slide over here and let me tell you what we are doing over here, because it's very important for you to sink in this in your brain. Hardware elements. We talked about this element already in great detail. Networking devices. We talked about a device on the network having network card and having some logical addressing, which is called the network configuration. And we covered this area pretty well. Okay. Now we're going to talk about this area over here. What is a server? What is inside a server? What are those components? And then we're going to also look into, let me just drill down this one. We talked about the networking in as a component of the IT industry. And we talked about the devices in the networking device, your device, laptop, desktop, or a server, their logical network configuration requirements, IP address, subnet mask, and gateway. We talked about the role of a switch. We talked about the role of the router, right? This is done deal. Now you understand the importance of the networking core component of the IT. It's core concepts. Now we're going to get into the hardware components, being that the hardware component is the major component is the server. Server is the hardware, one of the component, not hey, the routers and switches are also hardware, right? But that falls into the networking category or component. We're going to look into the server, which falls into the hardware um, component of the IT. Okay, server. What is a server over here, ladies and gentlemen? I'm going to teach only for like next maybe 15 minutes. Then I'm going to stop over there. I'm going to take all the questions you have in this world. Again, a server is something that's a serving on the network. If you went to Google website, you're basically hitting tons of servers. They are physical phenomena. Nowadays, they are also a virtual server too. If you don't get it, perfectly fine. Don't worry about it. Let's stick to the physical. What you see is what you believe in, right? Tomorrow, I'm going to show you the physical server. I'm going to show you a switch. I'm going to show you the router. Or maybe down the road, I'm going to show you. We'll see. And a server basically is like a desktop, but it's more beefed up version. It has the same components as your laptop and a desktop, but they're more durable. They're supposed to run 24 by 7 and 24 hours, 7 days, 365 days for years and years. By the way, I have a story on this one at AT&T and T and how I rebooted a server which was running for straight 3 years accidentally, and how it almost cost me my job. But I'm not going to share that story with you guys because you guys don't like stories. So let me come back over here. CPU. Now we're going to talk about the components of a server. There are specific components that are found in your laptop, desktop, and a server. What are those components? CPU, RAM, storage. What is a CPU? Everybody knows. Everybody knows these days. A CPU is the brain that runs all the softwares and operations. Memory is a short-term memory which store data. Hard drives store data permanently. Uh, this is one of the rack mountable server. Probably looks like a Dell server, and these are some of the basic components. Let's go deeper into this. If you remove the hood of the server, what you will find is you will find some storage devices such as hard drive, which stores your data, and then a motherboard, which is right over here. This whole thing is called a motherboard. This basically has some chipsets, it has some chips that enable all of these components to communicate with each other. And remember, you don't have to be hardware guru like Shahid. He knows everything about every single chip on this motherboard. I never get it. I don't need to get it. I'm not a hardware engineer. I am a Linux engineer, DevOps engineer. Yes, I need to know how these, what these components are. That's about it. Network card we were talking about. Network card is usually in the back of the server, and it basically provides connectivity. If you don't have a network card, you cannot connect to the switch. Remember I said the network card connects to the switch connects to the router. Yeah. So if you're missing a network card, there's no communication. Your server is not cannot be online. It cannot provide resources to other servers. Power supply, of course, turns on the server. Everything good so far? Okay. Let me see. I see over here hand. Yeah, you guys are telling me. Okay, so yeah, these are some of the components of your server. Now, go back over here. A little bit review on this. How about this? I just draw this. I just draw this on my screen and when I talk about this, let's just say this is my server. And then there is a CPU, which is the central processing unit. This is called the brain of your server. And usually you have memory slots right over here. So this area is called RAM, random access memory. It stores the data temporarily. And then somewhere over here, you have your hard drive, which could be nowadays is a solid state. Used to be a circular thing. This is called the SSD, which is like the fast, high speed storage device, which is hard drive. It stores the data. I'm going to say HD over here. This means hard drive, which also means storage. So, and then there is somewhere power supply over here. Power supply basically runs the power in all of these components. What else? In the back over here, you usually have a network card right over here. NIC, network interface card. This NIC, gets the good stuff like IP address, subnet mask, and the default gateway. And then what else? You also have a graphic card, which is like another chipset over here. This is called the video card or graphical card. Graphical card. Graphic card. The cable would plug into the monitor. This is how you see a display, right? You guys are all familiar with this stuff, right? So now, oh yeah, sorry about that storage part. What about the storage, Rick? Storage ports, yeah, I don't want to get too fancy, right? These people don't have a background. So this is power supply and RAM, CPU. Let's just say this is a server. Not let's just say this is a server. Now, you went to Best Buy, you got yourself a new server, or you went to Dell website, or you got yourself a new server. Now, you have to choose an operating system. I'm going to create a DVD over here. I'm going to call it an OS over here. You have to choose an OS over here to install on this machine. Okay, so let me ask you this question. This is where I would check your knowledge. When I install, by the way, you're going to install Linux on a server. You are going to do that. I'm going to show you how to do that. If you stick to this program till the end, you will be able to create a server, virtual server, install the Linux operating system, put it on the network, and make it connect to other machines. All right, that's the objective. If you can do this, you're superb, you're amazing. Once I install this operating system, let's say this is on a USB drive, on my thumb drive. I plug it in over here into the USB port. Everybody knows what the USB port is. But let's just say over here on the front USB port. I plug in this USB over here. Now, the server is going to install the operating system. You know the story of the operating system. Linux, Windows, Mac, Unix. Pick one operating system. Most likely you're working with the Mac or Windows. If you are rich and you're stupid, you're running Mac. And on top, you're running Windows. If you're rich and stupid, if you're a plain guy like me, you're running Windows. If you're a geek, you're running Linux. Why I call you rich and stupid? Because you're going to spend $2,000 buying your Mac, and then on the Mac, you're going to run Windows. That's called rich and stupid. If you fall into that category, my apologies. But that's how it is. But if you stick this USB and you start the installation process, let me ask this question. What is the role of these components when you install this USB? First of all, where the files are going to be saved, because when you install an operating system on a machine like a laptop or a desktop, it's supposed to take files from here, from the USB, and save it in one of these components over here. So what is that component where the files are stored permanently? What is that component that stores files permanently? This guy. Beautiful. Store files permanently. Excellent. You guys got that right. Beautifly. Beautifly. So I have two words that I regularly use. Beautifly when something you understand and you connect with me. Ugly fly when I say something and you don't connect with me and you hate me. That's ugly fly. So there's beauty fly and then there's ugly fly. Beauty fly is BF, ugly fly is UF. So because we're learning commands in Linux, we're going to do everything on the command line. So we need to understand, we need to build our own lingo. So beauty fly or ugly fly right now. This is beauty fly. Okay. So the files are stored permanently. This is USB. USB, sorry. Sorry about that. Now, once this operating system is installed and I power on this server, once this operating system is installed on this hard drive, because you told me it stores on this hard drive, and I power on this server using this power supply. So that's the power supply's job. I turn on the power button, the power supply powers every component, and you see some lighting over there. Which component on the server is going to give you a display on the monitor? Is going to show you a display on the monitor? Which component? A graphic card right over here. This is a monitor over here. Beautiful monitor. Okay, beautiful graphic card. Amazing, good job so far. Now, operating system is installed on the hard drive on the storage device. I power on the server using the power supply. The display is showed on my monitor using the graphic card. Yeah, so far so good. Now, how does this stored files, how do they, let me ask you this question, Now, what is the role of the RAM and the CPU to run the server? What is the role of the RAM and the CPU to run the server? The role of the RAM and the CPU is this. What you have stored on the server are the programs, the operating system files, the code instructions that this CPU has to process in order for you to see stuff on your monitor. So the stuff that's stored on the hard drive, as soon as you hit the power button, the stuff goes where? The stuff goes where? The stuff gets stored on this RAM chipset. Remember, when we did the USB install, during the installation process, the whole operating system gets moved into the SSD or hard drive. And now, as soon as I power on the button, the power supply powers all the components over here. I am starting to see a display on my monitor. How do I see the display on my monitor? Because this hard drive had some instructions to execute the code, programs that turns on my server, and this stuff gets moved into this RAM over here. Why? Why the stuff gets moved? Some of these files get moved to the RAM. And then what is the RAM's relevancy to the CPU? First of all, what is CPU's job? CPU execute programs. What's a program? Hey, every time you run the Zoom link, a Zoom application, this is an executable program which moves from hard drive into the RAM. A RAM feeds it to the CPU, and then the CPU somehow shows you the result on the monitor. This is how the Zoom application launches. Whenever you click on the Chrome, or Microsoft Edge, or Microsoft PowerPoint or Word, the stuff, the files that are stored for that program are on the hard drive, but they are slowly moved into the RAM. Not moved, copy. It gets copied into the RAM. The RAM feeds it to the CPU, and then it shows up on the display. Why? Because this hard drive fetching stuff for a computer, for CPU, to grab stuff from the hard drive, it's a lot slower. The RAM is faster. Remember, they're both storage. They both store data. They both store files. RAM, CPU can go and grab it quickly, faster. Hard drive is slow. This is how they're designed. This is how they're designed. So, whenever you run any application, I'm sorry, excuse me, the application, the files gets moved or copied to the RAM. The RAM feeds it to the CPU, and then CPU basically execute that program and shows on your monitor. And in order for you to get online, ladies and gentlemen, this network card has to have this configuration. Okay. Ladies and gentlemen, I think we're going to stop over here. I think I'm going to give you a recap of what we talked about, and then we're going to wrap up right over here. And let me stop my video for 1 second. And let me stop my video over here for 1 second. And let me go to my PowerPoints right over here. And let's go ahead and look at the presentation one more time. And so we can sum it up what we talked about. I talked about the definition of IT, the use of computers, networks, systems to manage information, support various aspects of your daily lives, and provide you communication and entertainment and innovation. So basically, IT, information technology, runs your all the applications that you see on your cell phone, on your laptop, are anywhere that you go today. You go to the auto shop, you go to Costco, you go everywhere. The IT industry is part of our daily life now. We talked about all of these things, how it's shaping the future, the AI, the data. And I'm going to continue to talk about all of these things because at first, they will not make sense to you. Slowly, as you understand the definitions, as you understand how things work, they will start to make sense to you. So don't be hard on yourself if you did not get everything today. I talked about the core components of the IT. And the core components is basically there are some hardware elements such as servers, networking devices, cables. There are some software elements such as programs, operating system, and applications. There are some elements such as the networking. We specifically looked at the networking and we broke down its elements. And we have to yet look at the data. We have to look into data. We have to look into software. We have to look into we just started looking into the hardware, one aspect of the hardware, which is server, which is relevant to our domain. This is pretty much done. We looked at it. We went into great detail. And again, today we're starting to look at the servers. What is a server? How it looks? What are some main components? The networking devices we already talked about. We talked about the importance of a network card. We talked about the importance of the switch. We talked about the role, not the important role of the switch and router. And we looked at the basic definitions, basic working elements in the networking. And further we talked about a device, your computer having a network adapter. We talked about the role of the switch, which basically connects devices within a network. We talked about the role of your router, which directs traffic between networks. So if you want to farm network, specifically LANs, you would need a switch to create a one LAN. And then if you want to connect that LAN to another LAN, another network, you would need a router. Every network has a firewall, which basically works as a access control, or you know gives you authorization to the network, or also blocks the unauthorized access. Then we talked about the basic networking. I told you specifically that every device on the network has to have a network card, and the network card has a IP address, and then each network card gets connected to, this is found on any device, right? So these devices eventually connect to the switch, and then switch and connects to one port of the switch, connects to the router basically takes your traffic on the outside world. And there is in between, there is a firewall over here, which basically filters the network traffic, which basically says, hey, which machine can come in, and then which machine can go out. That's the firewall role. If you don't understand this, not a big deal. At the very minimum, I want you to know what is the role of the switch, what is the role of the router, what is the network adapter, what is an IP address. And we talked about the physical cables and wires to make these connections between the switch and the device. You need a Ethernet cable, yeah, RJ45, or it could be done through wirelessly, like your cell phone. Again, I told you guys about the network adapters. Every machine needs to have a network adapter. They are built in. You will not see it on your laptop because there's a wireless card which broadcasts the signal wirelessly. But when you're working on a server, you will always see a network card where you can plug in a cable, Ethernet cable, RJ45 cable. This network card gets an IP address. That's how your server, your laptop, your desktop connects to the internet. We looked at the packet switch network. We looked at this model. We said that node basically refers to any device on the network. It could be a cell phone, printer, scanner. As long as it's connected to a network, it is called a node. As long as it has an IP address, it is called a node. It could be a storage device. It could be a server, laptop, desktop, or phone. So all the nodes on the network gets connected to the switch. As you can see over here, they're all connected using what cable? Ethernet cable. What type of Ethernet cable? RJ45. This is RJ45. And then each switch, one port of the switch, gets connected to a router. What is the router's job once again? Router connects networks. This is network 1, this is network 2. You want to connect them. You want them to speak to each other. You want them to talk. You want this machine to send a text message to this machine. You need a router in between, right? And then again, another picture on this one. I was talking about the rack, the importance of a rack. So how do you stack these servers in a data center? You install them. These are rack mounted servers. You stack them on top of each other, and there's always a switch that's found in a single rack where all of these devices get connected to give you a real perspective, and they connect to different ports using what cable? RJ45. And so, and then eventually this switch, one port on the switch gets connected to a router. This is not an industry standard router. And then this gets connected to the outside world, the internet. Again, we talked about the network configuration. Any node on the network requires this configuration. Configuration means this information. Where on this network card? How in the operating system? Are we going to learn this? Absolutely. Absolutely. So we were at the server. We explored the each component of a server. We found out that CPU basically execute all the softwares and programs. And the RAM is a short-term memory that temporarily stores the data. And storage stores the data permanently. For example, operating system files and the data. When you install the operating system on a server, it gets stored on a hard drive. When you run any application or when you boot up the server, the files, some of the files get moved into the RAM. RAM then feeds it to the CPU. CPU then produces results. And then we looked at under the hood in a server. We find the power supply, the network card, motherboard, CPU, storage devices. And ladies and gentlemen, this is the end of our today's lecture. 3 hours